Welcome, curious minds, to HFS Discovery. I'm your host, Joe, and today we're diving into the depths of science to unravel the mysteries of the early universe. So let's embark on this mind-blowing journey together. Big Bang explosion. A millionth of a second after the Big Bang, the universe was a strange and fascinating place. Instead of atoms as we know them today, it was filled with a peculiar form of matter, a liquid soup of subatomic particles and pure energy. Can you imagine that? It was hotter than anything in the entire universe, past or present. But here's the mind-boggling part. This unique form of matter hasn't existed anywhere in the universe for the past 13. Or at least, that's what scientists believed until recently. They realized that to truly understand the universe's first moments, they needed to recreate the unimaginably extreme conditions from when the universe was just a millionth of a second old. And there's only one place on Earth where they could attempt such a feat. Welcome to CERN, the world's largest particle physics lab. CERN is a haven for physicists where they put their theories to the ultimate test under the most extreme conditions achievable on our planet. I had the incredible opportunity to visit CERN and discover how scientists are delving into the secrets of the early universe. Trust me, it's mind-blowing. But wait, you might be wondering, why is it so difficult to study the universe when it was just a baby? Well, here's the thing. Imagine trying to look back in time using telescopes. Sounds fascinating, right? But unfortunately, we hit a roadblock when it comes to peering back to those very first moments of the universe. The early universe, as unimaginably dense and hot as it was completely optically dense. Picture a brick wall blocking all light. The universe was just like that, full of tightly packed electrons that caused light to bounce around instead of escaping. It's like being trapped in a dense concert crowd, unable to leave until the crowd thins out. Similarly, light couldn't escape that early universe until much later. So despite our powerful telescopes, we can't see anything beyond 380,000 years after the Big Bang. Nevertheless, cosmologists have some solid hypotheses about what the early universe was like. They believe that during this dense, hot phase, the universe was dominated by a state known as the Quark-Gluon plasma. Quarks and gluons are the fundamental building blocks of matter, and under normal conditions, they're confined within protons and neutrons. But in the extreme conditions of the early universe, they roamed freely in a hot, dense soup. This is where CERN's Large Hadron Collider, LHC, comes into play. The LHC is the most powerful particle accelerator in the world. By smashing protons together at nearly the speed of light, scientists at CERN can recreate the conditions a fraction of a second after the Big Bang. These collisions generate temperatures more than 100,000 times hotter than the center of the sun. But why go to all this trouble? Studying the Quark-Gluon plasma helps scientists understand more about the strong force, one of the four fundamental forces of nature. The strong force holds the nuclei of atoms together, and understanding it better could provide insights into how matter formed in the early universe. In addition to the LHC, CERN scientists also use other tools and experiments to explore these phenomena. Detectors like ALICE, a large ion collider experiment, are specifically designed to study the quark-gluon plasma, giving us a glimpse into the conditions of the early universe. It's important to note that these experiments are not without their challenges. Creating and studying something as ephemeral and extreme as quark-gluon plasma requires incredibly precise instruments and a lot of data analysis. Scientists must sift through billions of collision events to find the patterns and clues that tell the story of the early universe. The research being done at CERN is not just about understanding our past. It's also about shaping our understanding of the universe and potentially our future. The discoveries made in these experiments could lead to new technologies or theories that redefine our understanding of physics. In conclusion, by recreating the conditions of the early universe here on Earth, it's a journey that takes us back to the very beginning of everything, helping us understand the fundamental forces that shaped our universe. Thank you for joining me on this cosmic journey on HFS Discovery. If you're fascinated by the wonders of the universe and love exploring the mysteries of science, make sure to share your thoughts and questions in the comments below. We'd love to hear what you think about these incredible science